The second trend we're going to be talking about is ionic radius. And so if you say to yourself, well, atomic radius was the distance from the center of an atom to the edge of the atom, an ion should be the same. You are correct. So what happens is the ionic radius measures exactly that, from the center of the nucleus to the edge of your particular element's electron cloud. But in this case, your element has either lost an electron or it's gained an electron in the process of happening, or more than one, I should say. So we're not limited, but it's gained or lost some electrons. And the number of electrons it gains or loses actually plays a bit of a role in your radius. So there are a couple trends that you need to know with ionic radius. What ends up happening is that cations, which if you remember are the positive ions, oh, awful. Those cations are smaller than their parent atoms, and that is because of an increased proton to electron ratio. The nucleus pulls in more, and we'll get into that in a little bit more in just a second. Anions are larger than their parent atoms. So if we're talking about, it would be like F to F minus. Because of a decreased proton to electron ratio, and more electrons cause more electron repulsions. So here is the graphic that I think is really helpful. We are not ever really going to have to compare the size of one ion more than likely to the size of another ion. It's a pattern that we can follow, and we'll talk about that, but I just want to kind of show you. So in general, your cations, which are the positive ones, this chart here, the way it works is the gray atom is the regular element. The pink part here is the ion's size. And on the anion side, the gray side is still the regular atom and the blue side is the ion side. So you can see if I look at my cations from the element to the ion, the size shrinks considerably. If I look on the anion side or the negative ion side, the size goes up. And generally, the way that it works is that the bigger the ion charge, the more dramatic you are going to see the effect of that change. So if you see here, lithium, decent size, lithium plus is smaller, but not by that much. If we compare boron, boron is small, but then it also, when you go to boron plus 3, gets super duper tiny. And the reason for cations that their size shrinks is because you end up having a weirder proton to electron ratio than you had before. So if you think about a positively charged ion, what ends up happening is that you lose electrons to make that happen. So in the case of lithium, lithium loses 1 electron. In the case of beryllium here, beryllium would have lost 2 electrons and boron would lose 3. But the proton number stays the same. So let's imagine that this is lithium to start off with. And this is lithium's normal size. So here is lithium, and then inside in the middle, you can kind of hopefully see my fist. That is the nucleus. The number of protons here stays the same. But when I become lithium plus 1, this electron on the outside, it leaves. And what ends up happening is that the ratio, that perfectly balanced ratio of protons to electrons changes in the favor of the protons. And so what happens is I have the same number of protons in the middle, but now I have fewer electrons. And so those protons pull those electrons in closer. If I'm in the case of beryllium, now beryllium loses 2 electrons, so it's got 2 more protons for every, compared to the electrons, so it pulls it in even tighter. And in the case of boron plus 3, you have the an even more dramatic effect that it pulls it in tighter because you have 3 more protons compared to your electrons. So those are your cations. And in the same way, your anions expand in their size because of that ratio being off. So if this is, let's say, this is oxygen normally here, oxygen's normal size is this. We have, for in O's case, 8 protons, and normally we have 8 electrons in here. But if O gets 1 extra electron, it is going to have 9 electrons for 8 protons. And the 8 protons cannot hold all of those 9 electrons as strongly as they did when it was a 1-to-1 ratio. And when that happens, the electrons, because they're negative, they push out the size a little bit more. And when O becomes its normal ion of O minus 2, it gets another electron, and so it even more disrupts that ratio. And so now I have 10 electrons for 8 protons, and so my size grows even more. And so when we talk about them, it's always about the proton to electron ratio. In a cation situation, there are more protons than electrons, so it pulls it in. And in an anion situation, there are more electrons and protons, and the electrons push out and repel each other, and so your size increases. You will be asked questions kind of relating to that. So the example I want to go through is this one. How does the radius of Cl minus compare to that of Cl? And then, of course, we're going to explain that right now. You'll see the words explain, then you got to explain. So in this one, we'll explain. So pause your video, try to write out your answer, and then I will show you what I would expect to see for that, okay? All right, hopefully you attempted this. Get my paper aligned here, and then we'll go over what I think the College Board would be looking for something like this. So for example number 2, it says, how does the radius of Cl minus compare to that of Cl? And you can see I wrote the minus here, but oops, that's a mistake. So when we talk about these, Cl minus, if you think about your ratio, chlorine normally has 17 protons. So each of these have 17 protons, but in the case of Cl, it has 18 electrons, and in the case, Cl minus, and in the case of normal chlorine, it has a ratio of 17 electrons. So what's going on here is that in my ion, I have more electrons. So if I have more electrons, what that's going to do is it's going to expand my size because these protons can't hold on to things as well as they could when it was an equal ratio. Okay. If you are in a cation situation, you will have more protons than electrons, and then it pulls them in. So that's what we need to discuss in this explanation. So first thing we're going to do always is answer that question. How does the radius compare? So I'm going to say the radius of Cl minus is larger than the radius of Cl. Okay, so that's the first point, is just explaining it. Then I'm going to say this is because Cl minus has more electrons than protons. Okay, so more electrons than protons. Then I need to discuss what causes that. So what I'm going to do is I'm going to talk about this ratio and how that ratio being not equal causes problems. So I would say the extra electron on Cl minus increases the electron to electron repulsions in the atom. Making the size larger. And then I probably should talk somewhat about Cl as well. So I would say something like Cl has an equal number of protons to electrons, so it is able to hold its electrons closer than Cl minus. So when we're talking about these, you need to reference both of your elements. So we've got the answer here, and then we've talked about the difference between the electrons here and then what that does. I would say that this last sentence here is probably gravy, so you maybe wouldn't need to add that, but it would add a little bit to your answer. With all of these, we are not looking for a novel. You are probably only going to ever write 3 to 4 sentences to explain these. You don't need to do more than that. So if you find yourself writing a novel, stop. Just stop. We only want a few short sentences to get to the point. All right. Hopefully these two things are clear. Hopefully you understand atomic radius and ionic radius. If you find yourself having any problems, please let me know. We'll get things cleared up.